is ambiguous with the substitution effect dominating if sigma is smaller than 1, that is 1 over sigma, which is the IAS, is greater than 1. So you have two effects going into opposite directions. One says save more, which is the substitution effect. The other effect says save less. They go in opposite direction, and the question is which of the two effects dominates, and the answer is depends on the intertemporal elasticity of substitution. If you have a high intertemporal elasticity of substitution, that is, if sigma is much smaller than 1, then the substitution effect dominates and people save more if the interest rate goes up. If you have a low intertemporal elasticity of substitution, sigma is very high, so 1 over sigma is very low, then the income effect dominates. If the intertemporal elasticity of substitution equals 1, then both effects cancel out and you will have no effect on savings. Now, last thing, recall, that's something I also derived on Wednesday. Right? If you take, it's not obvious, but if you take, oops, that's nonsensical, that should be 1. It's not trivial to set sigma equal to 1 because you're dividing 0 by 0, which is not allowed. But we can solve it by using a thing called Hopital's rule. And what you can show is that, in fact, if you let sigma go towards 1, then this is just the natural log. So when people use a log function, it's a special case of an constant intertemporal elasticity of substitution function with the intertemporal elasticity of substitution equaling 1. What that implies is that savings does not react to the interest rate. So if someone presents you a model where the log function, where the utility function is log, then you know, this is a very special case. This is something that goes beyond this international macro class, right? If you understand that, because in Germany, for example, we had a couple of years when real interest rates were very low. So the nominal interest rate was very low and the inflation was very low. And so the real interest rate was close to 0. And people were super surprised by Germans saving a lot, nevertheless. And I wasn't surprised at all. I said, this is exactly what theory predicts, right? And why did Germans save so much? Well, they said, on the one hand, it's not so attractive to save, we know. But on the other hand, given those low real interest rates, we have to save more if we want to afford a decent standard of living in the future. That's the income effect. And so all this was not behavioral economics. It was plain vanilla neoclassical behavior that we could observe. And now let me just add on the second whiteboard, the second case, and let me cut that one short because I think the bottom line is suppose that case 2, we have income in periods 1 and 2. So you maximize U1, which is C1 to the power of 1 minus sigma 1 minus plus beta C2 to the power of 1 minus sigma minus 1 over 1 minus sigma, subject to C1 is Y1 minus S1, and C2 is 1 plus R, S1 plus Y2. What's new here is that you have an income in the second period. Right? This is something that we didn't have before. That's a super idea. Shall we? It's kind of windy in here. Shall we reduce the air conditioner a little bit? If that's. Oops. Let me. I see. Let me check whether there's a remote control.
I think all the air conditioners are centralized, so we cannot.
Okay. So I'll. Is it okay? All right. For me, it's great, right? Because maybe if you move after the break, you move here. It's a bit more. You're not exposed to so much current. All right. So let me just add the last thing. Oops. This little. Okay. So you maximize over S1, U1, which is. Thank you. Y1 minus S1 to the power of 1 minus sigma to the power divided by 1 minus sigma plus Y2 plus 1 plus R S1 to the power of 1 minus sigma minus 1 over 1 minus sigma. And what you get is S1 equals Y1 minus beta 1 over sigma 1 plus R minus 1 over sigma Y2 divided by 1 plus beta to the power of 1 over sigma 1 plus R sigma minus 1 over sigma. Now this is a two-period model, right? It's not rocket science, and still we see that things are more complicated because all of a sudden we have the 1 plus R here and we have the 1 plus R there. So if sigma is smaller than 1, so 1 plus R going up implies, so this is the numerator, and this is the denominator. D. So if 1 plus R goes up, then 1 plus R to the power of minus 1 over sigma goes down. If 1 plus R to the power of 1 minus sigma goes down, you're subtracting less, so the numerator goes up. And if 1 plus r to the power, if this is smaller than 1, then 1 plus r to the power of, if taking this to the power of sigma minus 1, this goes, the whole thing goes down if 1 plus r goes down, and if this whole thing goes down, it's the denominator going down. So savings goes up. Let me check whether that's what I have in my notes. Right. But if sigma is equal to 1, 1 plus r going up means the numerator goes up, the denominator is unaffected, so savings goes up. And if sigma is greater than 1, then you have the 1 plus r going up means the numerator goes up, the denominator goes up, and we don't know whether savings goes up or down. And the reason is